Okay, so today we'll be discussing design patterns, right? So yes, just recapping the last time's concepts. We discussed last time class diagrams, classes. We discussed about inheritance, how to represent inheritance, what is generalization, specialization. We discussed about association. What is association? Say, for example, driver is driving a car. Here, the driver class has an association with car class, right? So here you may have a autonomous car. So there may be 0 or more drivers, and there a driver can drive 1 or more car. So then there could be another relationship dependency. Say, for example, author writes a book or has written a book. So if you have a function, book is the parameter, so there is a dependency. We also discussed about message passing, and we discussed about aggregation and composition. So I have shared these notes into the folder. Please have a look, and you may ask any doubts. We also discussed solid principles, single responsibility principles, open close principles, Liskov substitution principle, interface segregation, and dependency inversion. So I've also provided the examples. What is a problem with having too many responsibilities for a class, and how to split a class with too many responsibilities to something which is having single responsibilities. Again, responsibility could be a big responsibility, but it should be related responsibility, and class should not have too many responsibilities. That means there should be a focus while you are designing a class or a module. We discussed about open close principle, that you should always have an interface and you should have possibilities to improve or add more components. Right. So in, yes, I see one question from Arun, that is it possible to solve design patterns as a LLD problem? See, design pattern is concepts which utilizes solid principles. So we'll see that how design patterns are utilizing solid principles, right? So all the principles, some principles are new. When we'll be covering, we'll be discussing. And when we will be discussing the system design as well, low-level design of any system, we will be revisiting them again, how to apply. But yes, you should understand this, and when designing any class or when designing any system, take care that all these properties or principles are satisfied. And we discussed about Liskov substitution and interface segregation principle. So this is all about the notes I have shared. Now today we will start discussion on design patterns. So Arun, can you just elaborate on what is exactly your request? I'm unable to understand it properly.
Yeah, sure, Tarun. Earlier I was preparing for an interview. During that time, I just opened YouTube and searched design patterns. I understood the design patterns, but somehow I keep forgetting every time. And so I understood as a I just as a remembering purpose, if I understand design pattern that way, I couldn't able to apply in real life. So as a low level design problem like chess problem or some how we solve a low level design problem, if we take that and if we solve in terms of that,
Yes.
So that way I can remember design patterns more easily. So that is
Sure. Definitely. Yes. We'll do that. We'll do that. So we will discuss various examples of design pattern. So yeah, I'll take care of that. Great. So
thanks, sir.
here, yes, I understood. I understood the problem. We'll give examples, relevant examples, so that you can remember it. Perfect. Yeah, because there are so many design patterns. It is important that you understand them well. Right. So let's talk about the different kinds of design pattern. So we'll be discussing creational patterns. There are different kinds of patterns. There is a structural patterns and there are behavior patterns, right? So now, can you list out all these patterns, design patterns, right? Tell me about how many design patterns do you know?
Factory pattern.
Okay, factory pattern,
Factory method pattern and abstract factory pattern.
Perfect. Abstract.
Builder pattern.
Factory. And then you have builder pattern. Yes. What else?
I know only these three.
Right. So anyone else who wants to add to this list? Yeah, you may talk also about structural patterns. There are many structural patterns. Right. So total, I would suggest that total patterns that you should know should be around, I would say, 20 patterns. You should know about 20 design patterns, right?
Strategy pattern, decorator pattern.
Okay, so these are behavioral patterns. So strategy pattern. Yes, and then you said what?
Decorator.
Right.
Decorator.
Decorator. Decorator is a structural pattern. So yeah, okay, good. So we have a pattern called decorator pattern. Yes.
Observe pattern. What is that? Observer pattern.
Okay.
Observe.
Observer. Okay, nice. This is again a behavioral pattern. The observer see. Yes. Anyone knows what are these pattern classes? What I mean by when I say, okay, this is a behavior pattern, this is a structural pattern, this is a creational pattern. What does it mean, basically? See, okay, even before that, let's discuss what is design patterns.
Right. So actually, I'm first time using the design patterns. Listening to this, yeah.
Right? Correct. See, as an architect, you will be dealing with lots of problems. Right. So design patterns, you can think of are the predefined solutions to common problems. Right. So basically, commonly occurring problems in you have software architecture. So, right. In software architecture, there are many commonly occurring problems. And What are design patterns? Design patterns are pre-made solutions to the commonly occurring patterns, right? So if you know these patterns, you can ensure that you are not having any problems and you implement best practices, right? Patterns are not algorithms, right? Patterns are the way to solve a problem or a best practices, set of guidelines and best practices. Okay. So now let's say what we'll be covering. When we are covering all these patterns, how we will be discussing, right? So first thing what you should understand is, as I said, when we are discussing, we should discuss the problem. What is the problem this particular pattern solves? Yeah. And definitely solution. So these are the two things we will cover. So here I would say for every pattern, we will be discussing problem, we'll be discussing solution. Yes. This you can call as purpose of the pattern, right? Basically, this is the purpose of the pattern. What else? We will also discuss about the best practices for the particular pattern. Yeah, because now you would know the solution, but why this solution? This is also very important part, right? So what are the best practices or guidelines because of which this is an effective solution to a particular problem? Yes. Basically, we will be also explaining the pattern. So this is an explanation to the pattern, right? So let me put this also in a rectangle. This color, right? What else we will discuss? We will discuss the UML diagram of the pattern, or what we can say that basically it is a class diagram or structure of the pattern. Correct. This is very important because you may implement it slightly in a different manner. Pattern is, there is also a lot of possibilities of implementing it. Exactly, there is no one solution which will be fitting all the set of problems, but yes, the guidelines are common. This is what you should understand. So this is also, we'll be discussing with each and every pattern. Next is definitely we'll be using, I'll be giving some code for the pattern. So these are the things which we will be discussing for each and every pattern. So you can think of a pattern is combination of all these all these things, right? So pattern is basically combination of, yeah, everything here. Right, so understood what is all about patterns, what are design patterns? So the motivation why people or architect came up with design patterns, again, there are a few people who have introduced the patterns. So there were 4 researchers or computer scientists. These are the name of the people who invented these design patterns, right? So these guys, they wrote a research paper, and from that, these patterns or these terminology has been arrived, right? So these people are also called as gang of fours. There, because there were 4 people here, right? So yeah. These are gang of 4. So yeah, basically these are the people who introduced these concepts, and that's why this pattern subject has came into existence. And all the patterns are based on object-oriented principles. So you should also understand that what all we have studied so far, we will be utilizing them, because every pattern is based on object-oriented design principles. Any questions, doubts on this? Right. Because as I said, there was a architect whose name was Robert C. Martin. I'll put here also. This is the guy who created the solid principles. Yeah, so you guys were having questions that why this is included in the principle or why it's not. This guy is also popularly known as Uncle Bob. Right? So you can see this guy's name and you'll be able to understand about, he also gives a lot of presentation sessions on software architecture. You can look into his videos and sessions. He has also written few books. One book is called Clean Code. He has also written a book on clean architecture. So these are few books by Uncle Bob. In the same way, here in the design pattern part, these guys have also written a book which is on design pattern. Yes, but that book is also very hard to understand. So if you have to read it and understand it, it's not very explanatory book, but yes, it is worth reading. But yes, simple to read book is, if you want to really read and understand things, there is Head First Design Pattern book. This is a good book, right? I would recommend to read for learning design patterns.
I started this set first, even thus that itself felt tough for me.
This is also tough. Okay. Yeah, but no problem. When I will explain, I'll simplify these concepts and then you will not find it tough, right? Then read it. I have read both the books. Gang of Four, I have also read Head First Design Patterns. So I'll be able to explain all them in detail and then you will understand. Right. Great. So now let's build up our list of design patterns, right? So this just for your vocabulary purpose, or this is what you can think of is complete list of patterns. I said we need to know around 20 design patterns, right? So what are these? The simplest design pattern is Singleton design pattern. Then we have, as we listed out, factory or factory method design pattern. Then there is, so all these patterns are just building upon each and every pattern. And these patterns are very much used in various programming languages, frameworks also. So I will give you some examples from the libraries also, so that you will understand it. Any more creational patterns anyone knows? There is a pattern called prototype pattern. Yes, this is used heavily in JavaScript. And then there is a pattern called, so these are the patterns. These are the 5 patterns which we will be using in creational pattern. Creational patterns. Okay, let's talk about creational patterns. What are these creational patterns? Any guesses?
These patterns are used in the time of creation of object.
Absolutely right. Yes, correct. So creational patterns provide mechanism for object creation. Yes. So if I have to define the pattern, so this is the definition. So creational design pattern basically provides various object creation mechanism. So it's all about object creation. So this is important part. And this is creational design pattern. Or let me put this in the box here. Right. So basically you always require this flexibility and reuse. Basically, goal of all the patterns are flexibility and reuse of code. So yeah, this basically I will put in the definition here. Right. So this is why you use design patterns. Design patterns are pre-made solutions to commonly used problems, right? So I'll underline solutions here and underline problems here, right? So, and definitely you want to achieve flexibility. Flexibility, why do you want flexibility? In your code, right? Flexibility leads to maintainability and extensibility, right? So that's why you always want to solve the problem, but at the same time, you have to have a solution which can be adapted, modified for various situations. Now, what do you mean? We'll cover one by one all of these patterns, and then you will become clear about it. Yes. Now, next thing is a structural pattern. What is a structural patterns? Let's list down this structural pattern. Then I'll define these patterns. Anyone has? We have one pattern, which is decorator pattern. There is a pattern called facade pattern, right? This is one pattern. We have adapter pattern. We have decorator pattern. We have composite pattern. We have bridge pattern. Flyweight. This is another pattern. And proxy pattern. See, this is very important class. And next few classes, they are going to be very important. And we will be learning these patterns, and we will also be learning how to apply them in real low-level design questions. Right? So these are about structural pattern. Any guesses about what are structural design patterns? Right? So as you would have guessed, it has to do with the structure of your code. Yeah. So basically this pattern provides how to assemble objects and classes into larger structures. So basically objects and classes are same. When you code, you assemble classes. We are all talking about classes, but yes, we will have to assemble classes into larger structures. And these structures, why do we want to assemble? Because we again want to gain flexibility and reuse of code. And your code should also be efficient. Right? So here I say flexible and efficient. So basically into flexible and efficient into structures. Yeah, larger again, you don't. So I would say the definition could be into the structures. How to assemble classes into flexible and efficient structures, or basically how to structure your classes into flexible and efficient modules. This is what you can modules, or I would better use the term components. Right? Components or modules or whatever you would like to say, you can use this. But yes, you have to assemble your, this is about the structural pattern. So these are the ways of structuring your classes into the patterns. I'm just putting down because now we have to list down behavioral patterns. So tell me about behavior patterns. We got few. Observer pattern, iterator pattern. Yes. Then we have a state pattern, visitor pattern, template method pattern. Right? There is another pattern called memento pattern. Okay, I'm having difficulties in recalling the spelling. Yeah, but yes, finally I got the right spelling. Memento. No, I got it wrong. Let me ask. Yeah. Okay. Yeah, this is the right pattern. Spelling. Then there is another pattern called mediator pattern. See, these names also describe it. There is also command pattern. There is chain of responsibility pattern, right? So these are the patterns for behavioral patterns. These are structural patterns. And finally, we have behavior patterns. Right. So now let's count how many patterns we'll be covering. We'll be covering Singleton, factory 2, 3, 4, 5. Here you
22.
have 5. 22. Oh, you counted. Very good. Maybe this is what I recall right now. But yes, hoping that while we will be discussing, we may also recall few more, right? So there are many patterns, but yeah, here this is 7. Yes, so 5 plus 7, 13 already. And then 3, 6, 3, 9, 10. 10, yeah. Yes, so yeah, 22 patterns total we will be discussing. But yes, maybe few more we may discuss. But yes, let's talk about behavioral patterns. What are behavioral design patterns? Anyone knows the definition?
Helps to decide what are the responsibilities of the classes. Identify what responsibilities a class should hold.
Okay, yeah, great, nice. So as you said that these are the patterns which will determine the behavior, or behavior is basically the responsibilities of so here I'll write provides responsibilities or behavior, basically behavior to classes, right? Basically assign, basically how to provide better English word is how to assign behavior to classes, and behavior means how to assign basically here irresponsibility or behavior to classes. Correct? Yes. So these are different categories of patterns, and these are various design patterns, and this is what we do. So here, let me also highlight this part, behavior or responsibility, right? Yeah, responsibility is important here. Behavior, we understand from behavioral pattern, very intuitive. How to structure classes into flexible components and modules. Basically here, I would say how to build components, modules, high level components, right? Using Yeah, modules, components, they are the same thing. Using classes, right? Yeah. How to build flexible and efficient high-level components using low-level classes, right? So these are the definitions of creational, structural, and behavioral design patterns. Lots of theory, right? Let's do some practical. So let me give you a problem. You need to solve it. You would have solved this problem Yeah, I'm just getting a problem. See, here now we'll discuss the creational patterns one by one. Yes. Ensure you or try to recall few principles. One principle which you should recall. Okay, tell me about when I say modules, what do you mean by modules or what do you mean by components? Anyone? What are components?
Maybe some kind of methods inside the program.
Yes.
Group of classes.
Right. Yes. But why do we need modules? Modularity is very important principle, right? So all the design patterns, they are based on modularity. Yes. Now let's take one example. Assume you have some application. So let's say we have an application. Let me, say this is your application. Let's say we'll take example of chess game, right? Online chess game application. Now in this application, you have designed lots of classes. Assume you have designed this, but now I give you a requirement that whatever is happening in the chess game, you take a file and this is your file. Maybe so we'll draw like this. This is your file. So what all is happening in the game, you need to log it. Yes. So what you need to do is you have to log. You know what is logging? Anyone? Give me example. What is logging? People would have learned about various other frameworks. Log4j, or there are SLF.
You mean
Yeah,
in the code?
Yeah, within the code we log it, right?
Yes. So for like if we go inside a method, then we can use a logger to print like information. So you're talking about that logger?
Right. Yes. So whenever there is some execution of the code, you log the steps which are getting executed. There could be traces, there could be debug logs, there could be logs about errors and warnings, there could be logs just for informational purpose, right? This is what I mean. by logging. So you have to create basically a class which is a logger class. Right? So now I have said you have to create a logger class. So what would you want to ensure that the logger works properly and it is efficient? So your problem is to create a effective logging system. Yeah, this is the problem. See, in your chess applications, there are multiple users. Right, so you have users here. So why multiple or two? How many users you have in your chess game?
Two.
Who will be playing your game at a single time, at a moment of time? There will be many, because there will be many games which are getting played at the same time. Right, so you have to log a lot of information because all these users, they'll be performing a lot of action. Yes, your chess engine will be also performing a lot of actions. So you have a lot of people here, right? Dot, dot, dot. So you have many users. When you have many users, what you need to do in order to handle your application? See, we are now getting into the system design of online chess game, but we are not going in low level. We are designing from high level. When you have many users, you will have some game class, right? You will have many classes here. We identified that time, that day in the previous class, we'll have class for players, we'll have class for board, we will have class for pieces, we have class for a lot of other stuff, right? Scores and maybe profile, friends, etc., etc. We'll have a lot of classes. So again, I need to put dot, dot, dot here. So these are classes in this online chess game. Yeah, they'll have relationships. But how many log files do you want? See, now you people are understanding the problem. Log file will only be one log file. Right? Correct, because if you have multiple log files, then you'll not get the sequence of operations, how it's happening. Right, because it will be inconsistent otherwise. So all the files, all the classes, so let me name these classes also. Board. I need to make it smaller. Yeah, this is board. This is say player. And there will be a lot of code here. And these will have to be logged. So player have to write here some content. Yes.
Tarun,
Yes.
one log file per user, or like one log file for entire chess system?
Yes, for entire chess system, one log file for entire chess system, because you have many users, thousands, maybe millions of users. If your chess game is very successful, right? So basically what, let me draw it in a better way. You have many classes. This is your system. You should have one log activity which should happen, right?
Okay. What is
In the chess game.
yeah? Why can't we maintain one log file per user?
This will not be helpful, right? Because assume you have a bug. Bug will come to all the users. You'll have so many log files. Which log file you will check? Yeah. So always you have one log file per application, so that you can look into the problem. And there could be scenario where when multiple users are playing, then there are error. You will always have one log file per system. Yeah.
Okay.
Correct. Anyone would like to explain this? Why we need one log file? Why not multiple log files? In Windows, how many log files? You have always one log files where you have sequence of events. Because otherwise, you'll not have the sequence of events. Right? So this is the requirement, that you should have one log file. So that some system administrator can troubleshoot, look into the log files and figure out what is going on. In case there is error, exception, it can look into it.
Yeah, Tarun. And I have one doubt.
Yes.
We have system.out.println and we have log4j,
Yes.
but in real application, production application, we don't use system.out.println.
Yes.
Why?
Yes, because that is slow. It'll slow down the system and it logs to the console. It's not permanent also. Right? You cannot retrieve it. Console is gone once you close the console terminal window. You have to store it in some permanent location. So log file is the permanent file. Yeah. So there's a lot of complexity about logging frameworks because they have to be fast enough, right? They have to write a lot of information. So there should be a buffering. There are a lot of optimization which is done. So these frameworks are very specialized frameworks. They can log very fast and without impacting the performance of your application. Because if you have too many system.console statement, your application will also become slow. So generally what happens in logging framework, they will run as a background thread. They will also have buffering. They'll be writing after the buffer is full and they will be updating the information. Another requirement is they need to be real time. So please note down all these non-functional requirements for logging system, right? So yes, this is a very important thing.
And there are different log levels, right? So why they divided into different log levels?
Yes, right. Because you would like to turn on logging and logging as per your need, right? So you would want your some switches. In production, you may not want to log everything because you want maximum performance in production. So there is a flexibility. When you are in development environment, you want maximum logging because you would use it to troubleshoot your application. Right? So based on your need, there could be different log levels. So log levels are generally info level. There is warning, errors, fatal errors, right? Errors could also be called exception. Fatal errors are mostly to deal with crashes. And then you have, so you have info and debug level logs, right? So these are various logging levels. So you can turn on and off the flexibility, your logging based on the various levels. So here, assume you have a code, info level will log even minor events. Debug level will log things which are important for debugging. This will be warnings. Warnings are error which may have side effect, but they will not crash the systems. Errors are exceptions, bugs in your code. Fatal errors are very severe errors. So these are different log levels. So maybe in production environment, you want these two logs. In your development environment, you want to log everything. So based on the log setting, so there is a configuration in logger. Based on the configuration, it will log appropriate events in the log file. Right. So now let me draw the configuration file, or there is some mechanism. Yes. For logging. So, okay. Let me try to make it smaller so that this looks good. This is, no way this text is not becoming small. Let me fix it. So, yes. Now I got this. Make this smaller.
Arun?
Yes. So
So
there
this-
is a configuration for log file. Yes. Tell me.
So these log files are nothing but some kind of a class data and code inside the permanent storage, am I right?
This is events. So log files are, I'll give. I'll give you some example. Yeah. So log files are something, some text information like this. Yeah. So probably sometime then application started. This is my log, right? Connecting to database, connecting database connection successful, right?
Okay, got it. It's showing the instructions, what happened, right? The events.
Yes, these are the events. So you will get something like this, and there will be events for each and everything which will be having, right? So when you turn on the configuration info, then all the information will be logged. When you turn on debug, then these logs will not get stored in the file, right? So based on this configuration, you can turn on either all the logs or some of the logs in the application, right? Now let me give you some code also. So how you will log. Yes, so just this is when I want to explain more and more, things get little messy. Yeah, no problem. But yes, coding example is very important. So assume this is your code. So you'll have some method logger dot application started, right? Something like this you'll do. So automatically the info level and all that information will be appended, right? So basically logger dot info will be the method here. And for debug, you will put some logger dot debug, right? And so you will have some logic here. And exiting is again, say info. So you will have info. So you'll have some code like this. Right? Okay, now I have exposed you some hints. So basically what you will have is you will have a logger class. You will say, okay, we'll have a logger class. In this, we will define the methods, which is debug. See, don't worry if I'm taking too much of time, because initial few design patterns I will discuss in detail, because then you will get a hold of how to understand the design and patterns. And then the remaining one I can move fast, because again, the basics and foundations are in the first few design patterns. Later design patterns becomes more easier to understand, because the concepts they are both based upon is built upon in the foundations. Right? So basically you will have a logger class in your chess game, which will be logging the information. Basically, your application logs will be generated by this class. Right? So now you have to create a logger. So all the classes will create the logger. What could be the problem in that case? You may have
Singleton class.
Yeah, so the best practice is have a singleton, because if you have multiple log instances, then you will spoil this game by having multiple log files, or there will be inconsistencies because multiple logger instances are there. So you need to ensure that logger is a singleton class. Although it will be called by multiple classes, player class will also call logger, board class will also call logger. But yes, how to ensure that there is only one instance of class is what is known as singleton pattern. So can someone?
Yeah.
How to ensure that we only have
Private constructor.
Okay, yes, absolutely, absolutely. Right. So
And we will have a buffer of size of like 100, and we will, while updating that buffer, that should be thread safe.
yes, yes, right, absolutely. So what you need to do is you need to create a class. Let's say our class is, let's call this class singleton or logger. Basically here we know the name of the class, right? Now how will you ensure that you should have a static variable of type logger, right? So I will define a variable. This is an object. So this is single object. Now you said we need private constructor, private singleton, or sorry, logger here. So this is your private constructor. But tell me why private constructor?
Because someone like they cannot instantiate multiple classes.
Yeah. So because you want to prevent the other classes to call this function. Yes. Because otherwise, if you allow others to call this function, then you'll get many instances. So you don't want others to call this constructor. So that's why you make it private. Clear? Next thing is, but then who will create? Maybe you will define a public method, right? See, and a static method, because you have to use this object. This is your buffer, correct? So public static logger get instance. This is the method. What the get instance do? It will check if equal to null. If this is the case, then you will create a new object, right? Otherwise, what?
Return the existing object. Logger, return logger.
Yes, return,
This dot logger.
right? So return log. Correct? So see here, if it is null, then it will return logger. If it's not null, it will do nothing. It will just return the existing object. So you'll always have one instance of the code. Yes. Clear? Is everyone able to understand this code?
Here there is like logger has to be initialized outside the if block, right? And
see this method I'm calling here. Final logger equal to logger dot get instance. See, this is static. So you can call it get instance. It returns a logger. You store this in logger and you use it to log the information. Right? Is this okay?
yeah, in that get instance, logger equals to logger, right? So
Yeah.
that has to be out of the if block.
Yes. Pardon, which is what is outside logger if block?
Declaration should be outside logger declaration.
Yes, yes, absolutely right. Correct. You don't need this declaration because it's
Directly written.
declared here. Yes, right. Absolutely right. You got nice. We are able to get the problems. Nice. There is one more problem. What is the other problem?
Synchronization.
This code looks good, but will not work. Yeah. Because
So-
if you have multiple threads, multi-threaded application, you may get multiple threads executing this at the same time. What if two threads are reaching at this place at the same time?
It will create two instances.
Yeah, it will create two instances. Because both of this will get null. Yeah, logger equal to null, both of this will be getting this part. So how to fix this?
Synchronized keyword adding to get.
Yeah, you need a mechanism to ensure this method is getting executed by only one thread at a time. This part. So you use a synchronized keyword. You can use a synchronized keyword. Yeah, so I would say insert here the synchronized keyword. Yes. This will make it thread safe. Even if multiple threads are calling, it will not have any problem. It will ensure that this is singleton. When we deal with design patterns, we only deal with single systems. We don't worry about distributed architecture. So this is your singleton design pattern. So now you guys will always remember what is this singleton design pattern. Right? Yeah, still this can have multiple instances, because if you are running the same online chess game into a distributed environment, then this may get one instance per server. And then you will have again many log files. So in case you want to ensure one instance across all the distributed environments or across the cluster, then use a database to store that whether the instance is already created or not, right? You may store this field here instead of storing it here. You have a Boolean flag in database. If you have that true, that means instance already exists. Return the existing instance, otherwise create an instance if it's false, right? Maybe is initialized, you can create. So this is how you will make it cluster safe, right? Even if your application is running in multiple distributed servers, you can even ensure that you have only one instance.
But in that case, if that is false, if it is already created, the instance is let's say we have 3 instances. In the first instance, we have created that object, and we have set the Boolean flag in the database, but that object should be returned, right?
Yes.
Where that object will be stored? In the instance only.
Right. Yes, absolutely nice question, because how the object will be returned, right? So you need to store the state of the object also in the database, and you should be able to create that object in that particular server instance, right? Nice question. Yes. So you can instantiate the object from the database values. Assume it has some, what is an object? Object is collection of properties. All the property values can be called as a state, right? So when I say there is an object called employee, right? What does it mean? Class is a blueprint, but object has some values. So the maybe name equal to, right? ID equal to, you'll have some properties. Yeah. So if I store these values in database, I can recreate an employee object from this state in the database.
That is similar to that of clone, but not the reference.
Yes, right? It's a clone, absolutely, right? Yeah.
It is not possible, I guess. Like if there are multiple instances,
yes,
every instance has to have a separate file. log
Yes.
file, if we maintain the one file for all the instances, there is no way to coordinate, right?
No, you can coordinate across multiple server nodes also. You need a central coordinator. Correct? So in the distributed environment, what you can do, okay, this is again, we are going a little bit off the scope, but yes, definitely it is something which you should know for system design. So I'm covering, it will hardly take few minutes. Assume these are instances of your chess game. Yeah. Chess 1. Your application is successful. Now you have many instances. Right? Now, I'll just don't worry about the name. You need to ensure that you have a logging done. You can create another server instance. Is log. Right? So whenever you have to log, this is the instance which will be doing. This is the server which will be logging information. So assume chess1 has to log something. It'll call this particular server. Here the instance will get created. It will log to a log file. Clear?
Yeah. Log4j, every, like, it will maintain the log files within the instance, right?
Yes. Right?
Server log something.
Yes, yes, absolutely.
So
Absolutely.
in that case, in case of log4j, it is not possible, right?
Yes, absolutely. Yeah, this is not possible in log4j. Yes. So, but this is, if in case this is the requirement, this how you will implement. Yes. Great. So this completes the singleton pattern. Now,
And there is one ELK stack, that is
yes,
elastic
ELK.
logging,
Yes.
something is there, right?
Yes.
So
Log
this,
stash ELK stands for. Yes, nice. Elastic search. Log stash. Kibana. Yeah. So this is full form of ELK.
so this ELK is similar to that you mentioned in the left side, right?
Yeah, this is still more complicated because now you have to implement a search. This is text search, basically text-based searching.
Maybe log
This
stash
is-
is similar to the left one,
Yeah, this is yes,
visualization.
absolutely, absolutely, right? Yeah. Kibana is about dashboard, creating dashboard and creating graphical dashboards. And log stash is about aggregating the information into multiple files. So basically how this deal is different. I'll tell you why it's different. It will, every server will log here. Yeah. We will have a separate class on this. Don't worry.
Okay.
Log stash is something which will collect the logs from all the file and put it into a single file. Yeah.
Okay.
Okay. So it's aggregator.
Okay,
So
got it.
user, you get that you have one log file, but actually it is extracting information in real time. It is ingesting the information to a central logger, and then you are getting the logger, right? So yeah,
Nice.
not use this because this was just to share you the limitation of singleton class. But yes, in distributed environment, yes, you are right. some other approach is used. Because again, no, if I have this, you have a single point of failure here, which is a problem with always system design. Yes, other applications, the performance you will not get. The logging will be slow. It will not be in real time. So, yeah. But yes, I have ensured that only single class is there. It could be log class or it could be some other class. So this completes the Singleton pattern.
Yeah, and in the Singleton pattern, what are all the solid principles that Singleton pattern aligns with?
Yes. So here, see, this hardly 2 lines of code. Yeah, 3-4 lines of code. Singleton pattern. You have this line and this method, right? And private constructor. So basically what you have to remember, constructor you have to make private so that no one can call this. The default constructor also will get overridden here. You have to create a static variable to store instance, whether the instance is created or return the instance, and this particular method. Yeah. So the only solid principle which is valid here is, yeah, definitely you have this class single responsibility, very simple class is there. But yes, you see here the concept which is used is encapsulation. Basically, you have a class. That's it. So no solid principle into action as of now. Only one object-oriented concept, which is encapsulation. Correct?
Abstraction.
Yeah, abstraction also, right? Encapsulation is a way of achieving abstraction. Okay, nice. What are you abstracting using get instance method? Right? You are abstracting everything with just one method, which is get instance. Yeah, correct. Data hiding. Yeah, you all are related actually. When I say encapsulation, always assume it includes data hiding. It includes abstraction. Right? Whenever I say data hiding, it also includes abstraction. Yes. So to external world, only thing which is exposed is get instance method. They call it, everything else is hidden from. So even you don't know whether it's singleton or what is it, you just call get instance method. So now let's cover the next pattern, which is factory pattern. Yes. Or let me give you another problem. In the chess game itself, you have to create various pieces. Yeah. How will you create different pieces? Because you have various kinds of pieces. So here, what all pieces are there? Okay, let me get the chess game also here, so that we will be able to use it. Yeah. Okay. So you have different kinds of pieces. Let me choose the white ones. You have knight, you have bishop, you have king, you have pawn, right? So these are different kinds of pieces in the chess game. So now, what is the problem with creating the pieces in the chessboard? You have basically multiple classes here. How will you represent each of these classes? These classes, say for example, let's take an example of knight class, right? Each of the class has different movement rules, right? So let me call a method move. Yes, this method will have different behavior. Yes. So let's talk about how would you create all these pieces in the chess game. Because one way is you create each and every pieces as individually, separately. Yes. And you have to also destroy these pieces separately. But then you are not in control that only 2 knights have to be created, 8 pawns have to be created, 1 king has to be created, 1 queen has to be created, and 2 bishops have to be created. So it's always advisable that you have an external factory which can take care of all these. Yes. So see, the problem which you get is what we told is low cohesion. Because if you have to modify your chess game, right? Assume you get some different chess, different kind of chess. Then you have to modify at each of the classes level the way objects are created. Right? So you got the problem that your logic is split across multiple places. So how can you take care of creating a chess piece? We can use a factory pattern.
Maybe we can group all these pieces into one class.
Yes.
Is that right?
Right, absolutely, absolutely. You have to put them into a one class. So that class could be called maybe we call this class chess piece, right? Maybe if you can think of some better name, always, but yeah. For now, let's call it chess piece. It has a method which is move. Can you provide the implementation of this method, chess piece and move method? No, you cannot. Because each of the chess pieces will move differently. So this is an abstract method. Yes. You may have a property also But methods, what else? What all other method you can think of? Right. So yeah, maybe other methods. There are no methods. Actually, these are the properties, I would say. So other properties are current location, right? And maybe then move will give you the final location. Maybe color. Color could be another property, right? So color has only two values. Actually, color is an enumeration. It can have only two values. One is white and one is black. So it could be color, could be either black or white. And so you can say color type. Yes. These are all the properties which are there for a piece. Yeah. But yes, we may also have this as an interface, which could be implemented by all the methods. Looks good? Because anyway, you have this method as an abstract method. Public abstract method. And this interface is implemented by all the pieces, which will be all the, yeah, maybe I'll put here. And let me move these things around. And this is realized by all these classes. Correct? So all these classes, whether it's king class, will have separate, will have a different implementation of move method. Yeah. Yeah, could be anything here, right? All different types. So this is the pieces, but now I am asking you the challenge is that you have to ensure that only one king is created, two knights are created, one queen is created, 8 pawns are created. So you have a business logic, complicated business logic. Yes. So what you can define is, you can define a factory. What we should call chess piece factory. And this has a method which we can call create method. Now let's write the implementation for create method. right? So what it will do, it will create a new king. Maybe we pass on color. We pass on what else? Nothing. Yeah, just the color is only thing which we require. Yes. And what you need to create? So maybe king K. Yeah. Then you have a queen Q. Yes. You can say new queen color. Right. And then you have to also create knights. Right. So you have, say here, knight. It's not mu, it's new. And now you have to create two knights, right? So you can have here two knights created. So basically we can call it knight 1 and knight 2. Yeah. Or better to put a loop, right? Yes, so this will create two objects and we may store it in a array or a list, right? So that logic anyway, you can do that, but yes, maybe let me do that here. So you will create here knight array. A new, basically this is an array and right. So you got this. Zero to two. Yeah. Same way you can do the for other objects, and for pawn you have to put 8. So you got this logic. Right. So yeah, so let's create for pawn. Here you have 8 pieces here. And here you have, yeah. Right, you don't need here because you have created this. You don't need here, you have created this. So yeah, for all the pieces you have to do. I'm not writing for all the pieces, but yes, I have written for queen, I have written for king, and I have written for king. Right? King, queen, knight, pawn, all these things are ready for you to. So this is your create method. Understood? But yeah, what are we gaining with this create method? We are basically abstracting things. Yeah. But yes, one more improvement which we can do is basically, if you see here, you can use here chess piece, right? Liskov substitution principle. Yeah. Is it clear? Step by step, I'm improving the code. Yeah, just to help you understand. Because earlier there was a problem. Yeah, you could not replace it. But again, you see here, there is a complication. I have to call the appropriate constructors. If I have to change the process of creating, I have to modify so many constructors. Right? So why not create a method called factory? Yeah, basically, or yeah, let's call this method itself chess piece factory. No, let's call another method factory. Let's create another factory. Okay, assume we have when we create the factory, we also have some themes where player can choose a plastic piece, or they can choose a wooden piece, or they can choose some customization. Right? There is some style or theme, for example. So what we can do is we can create a method, and this method is our factory method. So what we can do is if type is equal to, right? Basically, I need to use say equals method here, king, because, or you may have a piece type. Yeah, so, but let's assume we have, for the time being, there is a string type which we pass. Yeah. And if suppose passed value is king, then you create new king. Yeah. See here, we have got all on the right side, same object, which is the base class. So I can pass this chess piece. Yes. So now what I can do is I can put this logic inside my factory method. And here I have lots of conditions. So here, if it's queen, then queen. Right. So now I can replace this. Yeah, assume I have color also, because color is also important here. So we have say color here. Yes. And so on. Right. So it has for all the types this information. So here, instead of new king, what I do is I call chess piece factory. Yes. And I need to pass, yeah, I need to pass that type also here. So string type, yeah. And then you have the color type, or yeah, which is the enumeration black and white. Yeah, let's call it just color. And yes, so here you pass like this, and this is your, so here you pass the string, which is king. If you have to create king, you have to pass queen, if you have to create queen, yes, and so on. This same thing you'll replace. No, not here in this case. In this case, you will replace here. Yeah. And this is I. You guys are not telling me the mistakes. Yes, like this. So is better. This is about factory pattern. One more mistake. Is this will be in a class called factory class. Let's call piece factory. This is the class. This is a public class. Yes. And I can make this also public method. I need to make this public method. I can make this static method. So I can just call this piece factory dot, or I can, yeah, right. So this is better to have a separate class here. So I have separated out the logic of creating the pieces. So you will have a game class, and in game class, I'll call the create method. Yeah, this maybe is your game class. And in that you have a create method, and in your main method, you can create all the chess pieces.
Tarun?
Yes.
Yeah. So in the first create method, we instantiated all the pieces in the
Yes.
first create method, right? And now
Yes.
we have created a new method, factory, chess piece factory, and we
Yes.
moved that logic to this method. What is the benefit that we are getting? We just like shifted the instantiation from create to chess piece factory.
Yes.
But what is the benefit that we are getting?
Right. So benefit which we are getting is you are encapsulating the creation logic of each and every pieces. Yes.
Yes, in the first case where all the instantiations are happening in the create, actually we are creating for the chessboard class, right?
Mm-hmm.
Yeah.
Yes.
When we can also encapsulate all of this in the create method itself, right? For the chessboard class, it's all and finally we want for chessboard class, and for that class we can encapsulate in create as well. But again, like we are making into two classes, create and create factory. We can also make all the instantiations in the create as well. That also encapsulate in terms of chessboard class.
Yes. Yes. Yeah. This I can say is start game, right? So method could be named anything right here. So see here, this is my start game method, right? So first thing what you have to do is you have to create the pieces. And the pieces creation will happen in the piece chess piece factory. So this method is a single method. Here, maybe you have a lot of things to be done within this, right? This is just a simple implementation. So with this, what I'm doing is I am putting the code, which is very cohesive code. And if someone has to take care of chess piece creation, he just have to modify, he just have to own this method. Yes, he need not have to look into modify multiple classes. So that is the advantage.
Yeah, even in case of create method also, like creation, everything is created in one method, right?
No, it's not created in one method. You have different method. For knight, you have a new knight constructor. You for queen, you have a new queen constructor, and so on, right? You have 7-8 different kinds of constructors where your logic is defined. So let's so here you have lot of logic. Assume you have something here, right? Got it?
I can understand the cohesion, but we are maintaining all the object creations in one factory. Here also we are dealing with different constructors in the factory, right?
Is within if logic, yeah?
Yeah, within if logic, we are dealing with different initiating different constructors. If we
Yes.
have all of this logic in that create method, also like what is the like big problem? I am not understanding, but it makes sense to separate them. That is for sure. Like it makes sense to add all this in one factory. But even if we are maintaining in one method that is create, what is the problem that I am not getting?
Yes, yes. No, basically what, I should have also done is, you got it. So when I say the chess create factory, it should also be able to create that many, chess piece is fine. So what exactly is the benefit you are asking, right, of doing this? Yes.
Yeah,
If it
exactly.
is, you have a single method. Based on the type, you will be creating your entire logic of creating a chess piece is defined within a single method rather than in multiple methods. Yes.
We are using only one create method, right? How multiple methods?
Earlier, multiple methods. Oh, you are talking about this? No, this is just the client.
Yeah, client.
But what was creating was the constructor. Your logic will be there in the constructor. So I have now removed the need of all the constructor. Constructor is being called only by the chess piece factory. Basically, what you have to think about is you have a chess game here. Let me share you. So this is the chess board which you want to create. Yes. So there are internal components which are the chess pieces. Yes. So you want to abstract the internal component. You want one method to create all the pieces. So this way you may expose this piece class, right? And assume I want another kind of chess where you have these pieces, but some other additional pieces also. So what you can do is you can inherit this class, and this way you can add more pieces also. Since your logic is here, you're just when you add any new class, you don't have to update the creational logic. Yes. Basically, you will understand in all the UI frameworks, this is used. Now, the reason for using this on UI framework is based on various properties, you would like to create different things. Yeah. So here, based on the property, which is the type and color, you want to create different varieties of pieces. So you may use a configuration file, read that configuration file values, and you can instantiate in a very flexible manner. So, like I may have a file like this, where I specify what all I want to create. So like this, I may just pass on this configuration file to this chess piece factory class, and it can create all the chessboard, which earlier I could not do. Right? So maybe I also need to pass the color. So color could be white, and I may say white and black, and write this, right? So this way I can pass, yes, white and black, I would pass like this. Yes, so rather than, yeah, maybe I can have a configuration like this. So this provides me the flexibility of creating the chessboard from a separate factory method. So here you are avoiding type coupling. You are having a single responsibility. See here, what is important here is a single responsibility principle. You have a creation code in one place in the program, which is your factory method, rather than splitting into multiple places. Because the problem with that is that you have different kinds of pieces, so many different kinds of pieces. And if you keep your logic in different places, it will be very hard to maintain. Right? So this is one advantage. So the solid principles which comes into picture here is single responsibility principle. From this perspective, is it better?
Yeah.
Because we have here, see, I have put all the code here in the single method rather than so many constructor method. Constructor is also method.
Yeah. Okay. Now I understood that if I wanted to create king,
Yes.
I just need to know only the king string. I don't need
Yes.
to like what class to initiate
Yes.
and
Yes.
everything and
Absolutely.
all those things.
Yes. Yes. Yes.
So object creation is simple. I find
Yes.
in terms of client point of view.
Yes.
But why can't like when we have object creations in many classes, there are object creations happening. Here the object creation is moving to one particular
Yes.
class. So then every object creation has to be in one class only. But in real life, we see that every class has many object creations. right? Like did my point clear? A doubt
Yeah.
clear?
Yes. Now, good point. Good point. Yeah. Dependency injection. What is it?
Yeah,
It's bean.
dependency. Yes,
Bean.
dependency. Yes, yes, exactly. At one place we are adding all the
Yes.
object creations.
Right.
Is that a factory then?
Yes. Yes. Correct. Because it takes care of the entire life cycle. Basically, yeah, I'm giving you simplified examples. There is a lot of complication in this because you have to take care of the life cycle, and it is also about creation, having a creation in single place, and when to create also. This may depend because maybe there will be more logic. If pawn is reaching the edge of the board, promote it to king, right? So that logic could also come here. So there could be complicated logic which is placed in one place, and this simplifies a lot of things. But yeah, definitely there are drawbacks, right? So here with each of the patterns, we will also learn about anti-patterns. Because if
And one
pattern
more doubt
is, yeah,
related to that only. So here the factory is creating objects of one super type, one super class, right? That is
yes,
chess piece.
yes.
I have 3 different classes. Those are not related.
No, you are not creating only one superclass. You are creating an hierarchy.
Yeah, yeah.
This piece is a base class.
Yes.
You are creating knight, king, and any other kind of
Yeah.
pieces.
Yeah, knight, king, and all the pieces are related.
Yes, yes. They
Related
have to be
because
related.
of parent class chess piece.
Yes, yes.
But if we have class 1, class A, class B, class C, these 3 are independent classes. There is no super class for class A, class B, class C. Just simple 3 classes. Can I
Yes.
use factory method to instantiate these 3 classes and call it a factory pattern?
Yeah, right. See, if you have different classes which are not part of the same factory, is not part of the same hierarchy, then what you will have? You will not be able to do something like this. Yeah. We do that actually, which is in Java, we use a method which is, you would have.
There is no common type. Here the written type is chess piece.
Yes.
Here the written type cannot be 1 because 3
Correct,
different.
correct. Yes. But there we do sometimes that also, but that's a different pattern. Because yeah, sometimes you use class.forName and you pass the some full package name, right? Say you sometimes create this. Basically, how things are done here, generally we use it in JNDI, right? So something like this. Yeah. So sometimes you do this, or yeah, even sorry, I got JDBC driver, right? Sometimes you do this. I'm just trying to paste the snippet. Yeah. Right. So in case of device driver manager, get connection, sometimes you do this. this creation like this is just for improving the performance of your code. Sometimes, yeah, you may prefer not calling the constructor. When you call a constructor, it takes extra CPU cycles. And it has to go through the class hierarchy, instantiate things. So that is one disadvantage of the factory method, factory pattern. But other than this, you see the code is so much simplified, right? Which will not be possible if the hierarchy is not same. You will have spaghetti code which is very hard to maintain, right? Because the classes are unrelated. So why you are having the creation in one place? Better make it related and then create it. Yes. So that is the side effects or drawbacks of factory method and some benefits. So you have the benefits, which is this easier to add new kind of pieces, because you add a new piece and you just modify one method, right? So this provides encapsulation. It makes your factory also testable. But yes, at the same time, you have one more class, additional class, which is factory class. You have a complicated method, which is the factory method. In this case, we called it chess piece factory method. You may have more code, right? Because I'm writing new class, so I am adding more code. I also have delegated control of creating the objects to the factory. So this is important thing, because I am delegating, I am giving full control in one place, and anytime I have to play around with the number of pieces, I have only one place where I can update it. Yes. Correct. So this is basically the chess piece factory is the method which will create my entire overall board rather than single pieces. Because if you do individually at constructor level, you may be able to do a lot of fine-grained control. But here you are doing it in one place. So this provides you single responsibility. So this is about factory pattern. Right. So let's discuss the remaining patterns in the next class. The remaining patterns are, we also covered in brief the remaining patterns, which were so we covered Singleton pattern, we'll covered factory pattern. We will revisit this pattern. There is a very similar pattern, which is abstract factory pattern. And then we will have two other patterns, which is builder and prototype patterns. Right. So I'll share the notes and I'll give you this as an exercise. So to think about how best you can create a factory for chess pieces. Yeah, maybe come up with some better proposal. If you have some better proposal for creating the pieces, right? And then we will discuss what we should prefer. Assume as a group, we have to design this chess game. And we have now the task to decide about the implementation of chess board, how to create the chess board. So try out various approaches and we can discuss the pros and cons. We can do a group discussion on this. I would appreciate effective participation because when you try to do it in different way, you will understand the pros and cons, because things can be taught to certain degree, but better to learn by experiencing it. Yes. So right now, just take my word that this way of creating the objects are preferred in case of chessboard, because this is you are encapsulating the creation logic. Yeah, this green part is what you are encapsulating the creation of pieces. Right, and then next class we'll cover more patterns and we will continue building on the chess game, and we'll apply wherever possible the examples as per the chess game. Great. Awesome. So you guys understood the two patterns, or still there are doubts? Just say yes if there are more doubts, no if there are no further doubts.
One last doubt.
Yeah.
In case of creating object creation for subclasses, so every time we need to use the factory.
Yeah.
Okay.
You may create directly also the objects, because we have not made the constructor private. Yeah, you may have options to create via factory or not to create via factory. But preferred way would be to create via factory.
Okay.
Yes.
Yeah.
Right. But yes, as such in the pattern, you have, there is nothing specified that yes, you make the constructor private, but yes, this is definitely no preferred way. So why not always create using factory?
Sure. Yeah. Thanks.
Any other questions?
I'm good.
Okay, sure. If no further question, we can end the class. Yes. Great. And we will revisit abstract factory class. Abstract factory pattern and the remaining patterns. So today we covered two patterns. In the next class, I think in less than 3 class, we'll be done with all the design patterns. So this week we will be completing all the design patterns. Okay, see you. Bye.
Happy weekend.
Thanks, Tarun.
Same to you.